Diphtheria is a contagious disease that can cause severe inflammation of the windpipe. This disease is caused by Corynebacterium diphtheriae, which is where the bacterium produces toxins that can lead to many abnormal and severe symptoms. 10% of people whom are exposed to this disease die from it. Diphtheria disease is rare in developed countries due to the use of vaccinations. The transmission of the disease is person to person that is contracted from airborne respiratory droplets, from a sneeze or cough, or even contact with objects that are contaminated. Major symptoms of the disease are fever, chills, swollen glands, loud cough, sore throat, discoloration of the skin, increased saliva production. As the infection of the disease worsens, so do the symptoms. Difficulty breathing and swallowing, slurring of speech, shock such as pale and cold skin, sweating, increased heart rate, heart failure, and nerve paralysis. Host immune response. The bacteria that causes diphtheria is not harmful, unless infected with a virus. The virus injects its genes into the bacteria, which produces the severity of the disease. There is a breach of chemical and physical barriers when diphtheria enters the body. This causes the immune response to be immediate, which divides and works to prevent the disease spreading and colonizing in areas of the body. Innate immune response. Macrophages, which are located in the tissue of the first line of defense, have receptors on the surface of their bodies that recall the diphtheria's pathogen molecular movement of patterns. When macrophages first come into contact with the pathogens of diphtheria, they begin to attack the pathogen through phagocytosis. Macrophages enlist the help of neutrophils. These assist in the removal of bacteria. As this is occurring, the macrophages release chemokines and cytokines, which cause inflammation. This draws the immune cells to the inflamed area to prevent the bacteria from migrating. This is known as the inflammatory response. Cellular response. The cellular response is key for defense against the infection. The two categories of the T cells are cytotoxic T cells and lymphocytes. Cytotoxic T cells help in remembering the vital peptides which are located on the surface of the bacteria. These cells also induce the death of the cell to the infected area. Lymphocytes are vital in the immune response as they attack the exotoxin and the initial infection. These activate macrophages. They devour the pathogen. This then helps in the removal of the infected bacteria. Lymphocytes play a part in transforming the B cells into immunoglobulins, which are any class of protein that is present in the serum and cell of the immune system that function as antibodies. This eliminates the toxin. Humoral immune response. The humoral immune response encloses the transformation of the B cells, which turn into immunoglobulins. This process discharges antibodies which coat the pathogen. The coating of the pathogen causes and disables the pathogen from adhering and infecting the host cell. This is known as neutralization. B antibodies, also known as anti-fragmented cells, attack diphtheria, mainly the B component, which is responsible for adhering to the membrane and forming a channel for the toxin to flow. But if this is blocked by antibodies, this stops the toxin from entering and reaching the host cell to infect it. There are many diphtheria vaccines known as DTaP, TDAP, DT, and TD. TDAP and TD are given to adults, whilst DTaP and DT are given to children. Diphtheria is a combined vaccine. The components in the vaccine depend on your age and how many vaccines you've had before. As a child, you were given all three: diphtheria, tetanus, and pertussis, while as an adult, you get given boosters of each type. The diphtheria part of the vaccine is made from the diphtheria toxin and inactivating it with a chemical. This now inactivated toxin is called a toxoid. This causes the disease to diminish. The vaccine has decreased the numbers of diphtheria by 90%. Vaccines stop disease through injecting a mild version of the vaccine into your body. Vaccines are injected into the body and are weakened by the antibodies, and they stop the disease from spreading. or you'll get a mild version of the disease, like high temperature. The antibodies that are fought off the disease remember the disease and are able to attack it when it invades the body and to prevent against the infection. Public vaccination programs. New South Wales government has set up a website that gives information about diphtheria and the causes, symptoms, and also the prevention. This website explains in depth what diphtheria is and how it is caught. It also explains the minor and major parts to the symptoms. This website also has links in the description to a scheduled timetable for what vaccine should be given at particular ages. The website allows people to be aware of the diseases around them. The cause of this is that people are aware and educated on this disease and will get their children vaccinated. The outcome of this is that there will be an overall decrease in the rate and numbers of diphtheria over time. World Health Organization's expanded program on immunization. This is a program where they want to immunize every child so they are unable to contract the disease. In 2010, they had given 3 doses of DTP, also known as diphtheria, tetanus, and pertussis, to 85% of children. World Health Organization has extended this program and are trying to get all people to be vaccinated so they are unable to contract diphtheria. Overall, this has helped in the decline of people contracting diphtheria. Vaccine programs. The New South Wales Australian Government Department of Health website on the Immunisation Program, Australia, has many links and informative pages. This website tells people about the program and who runs each particular part. It also tells you about the immunisation and why you should immunise your family, with a schedule of when to do so. This website is easy to navigate through. It allows people to ask questions about any concerns they have. It also has a list of diseases that can be vaccinated for and what the cause, symptoms and preventions are. This website allows the community of Australia to gain knowledge on the diseases and preventions to them. World Health Organization has a program called Close the Immunisation Gap. This is a global campaign that raises awareness of vaccines and how important they are. This program informs people how 1 in 5 children under the age of 5 die from diseases that can be prevented. Also, how millions of adults around the world aren't properly protected from highly contagious and detrimental diseases. During the week of vaccinations, the program highlights the rise in immunisations and the targets of what the World Health Organization wants to achieve by 2020, which is having all people vaccinated. This program has helped many people survive and not contract diseases. It also informs people on the severity and lack of immunisation.